Voilà, donc Mohamed Hamdi, directeur développement Paul Razella. Je gère en même temps le centre d'innovation. Donc j'ai préparé mes slides en anglais avec votre permission, donc je vais parler aussi en anglais, donc si ça gêne personne. Voilà. Donc my presentation is about smart energy monitoring. This is one of the prototypes that have been built this year in our innovation center. We have around 5 or 6 other prototypes. And maybe I will say a couple of words about the strategy of the Innovation Center. Everything we do is in collaboration with industry and research. So it is the government, industry and research working together in order to build new product. And interestingly, IoT is the driving technology for the Innovation Center. So everything we do is IoT enabled with multiple partners from international labs, from France, from Belgium, from US, from Canada, and also from the local ecosystem. And the model is articulated around 3 basic rules. First, when you enter at the innovation lab, you must be either an entrepreneur or a PhD student or a student somehow. And second rule, your objective must be to prototype something. If you fail to prototype your idea, you failed your stay in the innovation center. This is the second rule. And the third basic rule is that everything is free in the innovation center. Your stay, your access to the platforms, the technical support, the non-technical support, everything is free. But when the prototype is there, when you come up with something validating your idea, then the revenue share model is applied. Every party that has contributed somehow to building the prototype must earn something based on royalties or based on part of the startup of. So these are different models, and I don't have time to explain. But these are the basic rules, and here it is one of the products. So I will be quick because this is the last presentation before lunch. And the scope, yeah, not the last. Okay, sorry. The scope of the project is about energy. So here you can see that energy consumption around the world is evolving quickly and dramatically. And 2010 was the year during which an exponential increase in power consumption has been noticed. The main question is, do the energy monitoring solutions available today adapt to such evolution? Because monitoring begins with first metering, then you have to adapt to the context, and finally you have to provide substantial and understandable data to the user. Here it is a problem of scalability because the consumption is growing exponentially, but the solutions are not so adaptive. So our objective in this project has been to develop and to come up with a smart energy monitoring solution. Of course, you may say that there are tens and tens of existing solutions in smart metering and energy monitoring and all of this stuff. But we identified some of shortcuts or drawbacks in these solutions. First one is context awareness. Some of these solutions, especially the billing solutions, they are very efficient when you project them on the billing cycle, because when you pay for power, this is a cyclical process. But one of the basic questions is real-time context awareness. When, for example, you have some phenomena with respect to energy consumption, and you have to adapt the way you consume energy based on the context. The context can be the temperature, can be your physical presence, can be the number of audience here in the room, so it can be whatever. Here, the existing solutions, or much of them, fail to cope with this problem, with context awareness, and especially with real-time context awareness. Second one is that most of these solutions are very complex, let's say, to use by the end user, or to be effectively to have an effective added value for the end user. Sometimes these numbers are very complex to understand, and instead of giving added value, they render things more complicated. Another shortcut is about easy interaction. When the solutions is or are very efficient from the technical point of view, but you cannot interact with the solutions through dashboard or through, for example, through your smartphone, through mobile applications, these solutions are not easy to go to the market. And this has been beyond our choice to go for the IoT to solve this problem or these problems. So I will skip some slides. The main advantage of using the IoT is in this slide, because before the internet was just like that, but now the connectivity graph is really very dense, and interestingly this is proportional to the market. All the people and all the objects that are connected to the internet are your potential customers when you develop such solutions. And I will see the IoT versus the internet. Our project is called ENEMON, Energy Monitor. The basic functionalities is, of course, to gather data about consumption, to calibrate and to correct the errors, to transmit the information in real time, to provide analytics, and to do context-aware decision making. When you read this, you don't see a substantial innovation. But the innovation is in the context, because on the opposite of existing smart meters, some of them are developed by Ericsson and some by other manufacturers, the added value is that we can measure the energy consumption at the finest possible granularity. This is per power supply. The other one are mainly stick to the building. And the idea came really from a problem that we have actually in the Technopark, because one of our revenue sources is to rent the buildings. And sometimes you have a floor, and inside the floor you have 4 or more enterprises. But you have only one smart meter for power, only 1 meter for power. They're not smart yet. And the problem is how to bill energy, or how to build power to these 3 or 4 enterprises. The rule we apply right now is to divide simply by 4, by 3, which is not fair, because you can have some servers on rack and they consume as much as a whole building. That's why our objective has been to develop this solution to go to the finest possible granularity. And the prototype is already there, and we implemented it already in the innovation center itself. So now it is in the power distribution table, disjoncteur, and we can estimate power in real time in every fiber in every port of this power transmission power metering table. And the second is the multiplicity of the way you transmit. It supports NRF, it supports Wi-Fi, Ethernet, so it supports multiple types of connections. So the prototype is already there, and I will finish by this slide. It might be too complex to illustrate, but for me it is the most important one. Why? Because through this slide you can see that the prototype is the platform to develop other prototypes. We invited many people to come and see our prototype, and we also invite you to come and see. That's why I didn't put any pictures, to make suspense and to make you come and see it in live. But the output is that first Now the prototype is not only a smart meter, it is connected to another prototype developed in the Innovation Center, which is a social network for the Technopark. And now the social network integrates objects. And the object, for example, one possible scenario is that the object tags itself. For example, the lamp tags itself as off or on. Another object may be the GPS sensor on my car. And when you couple this information, you can think about interesting scenarios like saying, I left my office and the lamp is still on, but the lamp is connected to the internet. So it can see that I'm away from the GPS of my car. So it can turn down automatically. This is the Internet of Things, because it's not only to connect the object to the internet, but to adapt to the context. So not only sensing, but also actuating and also reacting, as you have seen in the first presentation. This is the first connection, connecting the prototype to a smart to a social network, and also you can see this working. And the second one is not working yet, but it is a very interesting scenario. It is because we have invited a startup called Digitas working on blockchain in order to develop smart wallet. And the scenario we are building with this startup is to implement a pay-as-you-go model for power. For example, you can buy 5 dinars, 10 dinars, and the system will be off for this amount of money. And it will send you some alarms before you deplete your amount. And this is a new economic model that can be interesting for some operators. So this is globally the context, the technical context for the prototype and the overall context. And even if some of you come up with the new ideas, we can integrate them. So it is an open model, and thank you for attending the presentation.
Thank you very much.